All right, greetings and welcome to Code Quickie. And today we're going to be looking at recommending products using Cloud SQL and SparkML, which is Dataproc. I'll change the title later, but that's okay. So just a quick overview of what's going on here. When you're dealing with Google Cloud Platform and the products, and you're dealing with big data, right? There's several different products you can use. If your storage, there's a lot of options going from Cloud Spanner to BigQuery to Bigtable to Cloud Storage. And then when it comes to dealing with your data, whether you want to go ahead, use Cloud SQL, whether you want to use Bigtable, Dataflow, Dataproc, Data Studio, Data Fusion, and so on. So today what we have, our use case in this lab is we have listings in our housing market and we have ratings from our users or our clients. And we want to turn our data into a training platform that our machine learning model can use in order to provide to for our new customers, when we get new customers, in order to produce the best recommendation, so our brokers, so our realtors can show our new clients which listings that they should send them first in order to get the best sale based on the machine learning model. And recommendation in Cloud SQL is good when you have transactional data, right? If you have a large market, if you have a small market, right, it needs to be updated daily. You could probably use something like BigQuery, the basics where there's a lot of support. But if you have a lot of products, you have a lot of users, probably not in a housing market, more like Amazon Marketplace, where they really push out getting reviews after a user buys the product. They have millions of items and they have millions of more customers doing reviews daily than something transactional like Cloud SQL. To have these machine learning jobs run at optimum is the best. So enough of the overview. Let's go into the basics of how we're going to go about it today. And what we want to do is we want to go ahead and create a Cloud SQL instance. So what I want to do is I want to go to console.cloud.google.com, go ahead and look for SQL in the API on navigation. I already have it pinned. What you always want to do when you're working with new APIs, you always want to pin them. If going back and forth, looking through, you can just access it at the top. So what we're going to do is we're going to go to SQL, and we're going to go ahead, create instance. We're going to choose the MySQL option, right? And then we are going to go ahead and name our instance ID rentals, give ourselves a root password. I already have a password for this. The location, we want to know the location and the zone, especially. For the zone, we're going to choose US Central 1-A, and the database version, want to notate as MySQL 5.7, right? Configuration, if you want to read, but there's a lot of things in Google Cloud Platform, as you can see. The details want to leave out. I just want to focus on getting the project done and getting paid. So as you can see here, I already have my SQL instance set up. Once you set this up, once you hit create instance, it's going to take a while to set up. So, but don't worry, you don't have to pause the video. We can do more things. Next thing we want to go ahead and do is we want to go into our Cloud Shell. We want to go into our Cloud Shell, and what we want to do is we want to go ahead and set the project, right? Set the project ID. So we set the project. So we know when we're asking for resources and we're trying to access Dataproc and Cloud SQL through the command line, it knows which project to grab that we are referring to. So as you can see, our Cloud SQL instance was created in GCP data certs. We can go ahead like so and set the project here because Cloud Shell can't pick that up. And then on the AC, ever making an API call, basically the overview is that through the UI console, through the SDKs, the software, whether you're using Python, Java, or whether you want to use the UI console, right? Always what you have is a REST API beneath it and acting in place. So that's what's going on here. And you want to authorize Cloud Shell to go ahead and make those REST API calls as well. So Next, what we want to do is we want to go ahead and connect after. We want to go ahead and connect. But like I said, it was taking a while. It's going to take a while for that Cloud SQL instance to set up. So what we want to do is go ahead, have a place to store your data. And now what I want you to understand is that when you're dealing with big data in Google Cloud Storage and GCP, Google Cloud Platform, there is storage and there is compute. Compute should always be separate from storage. Our compute here is Dataproc, and storage here is Google Storage. So what we're going to go ahead and do is create a bucket. Now, a bucket is like a file system. It's like one computer, but just the storage part. Just the storage part, like when you open up the computer, you enter into the directory, the C directory, that whole drive is your storage bucket. So what you're going to go ahead and do is you want to name your bucket the project ID, like I have here, GCP data certs, right? And as you can see right here, GCP data certs. And what we want to go ahead and do is in the Cloud Shell, we want to go ahead and copy from a sample bucket. We want to copy these two. We want to go ahead and copy accommodation CSV, right? That we're going to need this later, and we're going to need rating CSV. You want to go ahead, copy these into our cloud bucket, and you want to take a look at them, right? Go look at what's inside the data that we're working with, like accommodations. Right now, you can see some titles. You can see some CSV values, ID, cottage, what the type is. Right, cottage, castle. Right, so we have castles. Right, so I guess since we're working with castles, we can use GCP for machine learning analysis. Right now, what I want to go ahead and do is after this, we want to go ahead and get our Dataproc cluster set up. So we want to go is to Cloud Dataproc, head over to our clusters, go ahead and create a cluster like so. Want to leave the name, the region, and then the zone. Just remember the zone that you went ahead and created the Cloud SQL. You also want to create it. So the region was US Central 1. The zone is going to be US Central 1A, as I mentioned earlier. And then for the machine types, for the master node, M1 standard 2, and the worker nodes, M1 standard 2. And what we want to do after now is go ahead and create, and this will also take a while. But as your clusters are going ahead and creating, our SQL instance should be set up, and let's go ahead and set up the rest of the SQL database. So what I'm going to need you to do is go ahead and copy is first things first, we want to go ahead and connect to our SQL instance in Cloud Shell. So we have 2 Cloud Shells already set up for us. But what we want to go ahead and do is, right, I swore I set the project in here. Apparently didn't see that. That's okay. But let's just go ahead and set the project. All right, now what we could go ahead and do is connect to our database. Now this takes a while, actually. So what I recommend is that once you go ahead and connect to the database, that you try do your best to keep this tab open, go back to it, type in select star from a certain table, because once this connection gets lost, because Cloud Shell on top of my losing connection to my SQL, you might miss by accident close the tab, or if you leave Cloud Shell open long enough, it's going to cancel, right? Because Google Cloud Platform, what they have is resources. They allocate you a resource, and when you're not using it, their machine learning models say, hey, take this resource. We need it somewhere else. So I'm going to go ahead, password, and do my best to try to leave that open. So now what I need you to do is go ahead, copy this code, and run it in your SQL console that you're in right now. Go ahead and press enter. And what's going to go ahead and do, it's going to go and create the recommendation table, right? Which is what the machine learning model will populate, the ratings, the user ratings, our client ratings from listings past, and then accommodations, the accommodations that we have in our housing market, right? It's going to go ahead and create those tables waiting to be filled. All right, and now what I need to do, now that we have our tables ready set up in MySQL and we have our CSV files in cloud storage, what we want to go ahead and do is we want to head back to SQL and we want to go ahead and import. We want to go ahead and import that data into our tables so our machine learning model can have something to work with. Our Dataproc, right, has something to work with coming from Cloud SQL. So go ahead, go over to SQL, go over to our created database cluster, which is or SQL instance, which is realtors, hit import. And what we want to go ahead and do is go ahead and choose a file we like to import from. We browse, head over to a bucket we created and copied over the CSV files accommodation for this one, right? We choose CSV, we choose our database. The database you just created is recommendation Spark according to the SQL as we see here. And the table is, yes, you get the accommodation. So, right, we're going to go ahead and import, and also the same. So also the same that you see here. Once you click import, right, this doesn't take too long, but I just want to point out that the table for the properties that we have in this page, right, represent the table here, and you fill them with the values as needed. And yeah, I know you don't really get to select from here. So just want to point this out, that it is the Google storage URL. Okay, so once we have that, what we want to do is just go back into SQL and we want to explore. We want to play around with it. So say for example, you want to look at some of the ratings that the users have in here. Right, use recommendation Spark. Oh, empty set, that's interesting. Wow, probably do have to populate the table again. That's okay. Let me go ahead and pause the video as I populate the table. Or you guys can watch me populate the first table. And then work with the second table. Go ahead and browse. Rating. Go ahead and select. Recommendation Spark. And the table is name is rating, like so. All right, now what I'm going to go ahead and do is try this again. Right, and now we see our ratings. Our ratings given here. Let's go ahead and limit. This is a master table. Right, and we could see the user ID, the accommodation ID, right, and then the rating that they gave the accommodation, right? So the accommodation usually has a title. A bit lengthier to try and join these tables. I don't want to write out this SQL right now. We'll see it later, but we could see a user 18 gave certain accommodation number 1, rating number 2, and the same user gave the accommodation of 10, rating number 1. But as you can see here, we can see user 12 gave that same accommodation, that house listing, a rating of 3. So a user of type 12's personality would like accommodation of 10, other than a user of type 18's personality would like accommodation the accommodation that is associated with the ID of 1. And that's what we want a machine learning model to produce for us, so that our realtors can go ahead and, like the project goal on the sign, show the right house listings to the new customers that we see. Right. So we want to see how many ratings you have in this database. Right, you have 1,100 ratings. Not enough for a machine learning model, but it's good enough to get some sort of result, some sort of, to help our readers with some sort of idea. Get some of the statistics that we have in here. Okay, so we see a number of ratings, distinct user ratings, right? So we have 25 users who rated on about 20 to 10 to 20 different listings, and the average rating is about 2.5, right? So we have some bad listings and some good listings. Probably the cheaper ones for those who are lower income and those who are high income, right? We have good places as well, right? So we want to see which user provided the most ratings, right? So user number 16, 75 ratings means they probably moved around a lot from house to house. But that means we have a lot of rentals, we have a lot of house listings, or these are duplicates from the user, right? So now what we want to go ahead and do is, now Dataproc should be ready and up to go. What we're going to go ahead and do is, after this, we want to set up our cloud Dataproc to connect with Cloud SQL as needed. So what we're going to stay in our MySQL, and what we want to do is we're going to go ahead and type in vim authorize.sh, and want to copy and paste this code, and want to take a look at it, right? And we want to see that our cluster name, our Dataproc cluster is rentals, right? As you can see, let's head over to Dataproc a bit. Rentals, right? Want to see our Cloud SQL is also rentals, right? And our region or zone is US Central 1A, as given from our Dataproc and from our SQL, our Cloud SQL. Great. So now what we're going to go ahead and do is we're going to go ahead and run. We're going to do a chmod command, a little bit of Linux here. Cloud Shell is based off of Linux environment, Debian, if you want to know. .sh, and now we go ahead and run it. And hit continue. Yes. Right, now this will take a while, but after that, Dataproc is ready, is authorized now to go ahead and work with our Cloud SQL instance. Right. This will go ahead and take a while. But what we want to go ahead and do is go ahead and grab the code that is our machine learning model, right? And this is going to be a Python script. And in Dataproc, we are going to be using PySpark as our data engineering all software. Right, so now I want to take a look at at our train and apply. So we're going to do cloud. We're going to type in Cloud Shell open, train, and apply. I'm going to take a look at this code here. Right. So you can see that first we need a driver, right, to connect to our SQL. It's not so obvious that you need a driver, but we need a driver, and then we need to use their URL syntax in order to connect properly to the SQL instance, so that when we make commands, right, they get sent to the SQL and they're properly authorized, right? GCP authorization was one thing, but another thing we need to actually, it's still in MySQL. So now we bypassed GCP authorization, and now we're trying to work with SQL authorization. All right, so first, we want to go ahead, grab those ratings. We want to grab those ratings and accommodation, everything that we need for our machine learning model. They want to go ahead and train right here. And then a lot of code takes place like here. I don't want to get into it, don't want to throw you guys off, but I just want to make some important edits, right? So the edits, as you can see, I have this as a table, Cloud SQL IP address. We want to go ahead, grab like so. Cloud SQL database name, recommendation Spark, user is root from MySQL. Every time you start up a new MySQL instance, the user is root. As you've created it, and the password from earlier, I have banana bubble 732. Hopefully that made anybody laugh. And after that, we want to go ahead, hit file, hit save. Even though there's autosave, you know, I should even tell you that, right? There's no autosave. Autosave never works here. Want to go ahead, hit file, and then save, right? So by this time, right, Dataproc is already authorized to work. And what we want to do now is we're not going to run anything in Cloud Shell. We're going to be running things in Dataproc. So we need to move our data into storage with the gsutil command. CP data asserts. And now what we want to go ahead and do is we want to go into our ready to go Dataproc. We want to go over to our jobs, right? No jobs to display. We want to go ahead and submit a job. Choose the job type PySpark, and then the Python file, right, is a Python that we have in our cloud storage. And then train and apply, as you can see. Let's see if you're able to copy the path. Probably not. That's okay. Yeah, they don't give us a path. Oh yeah, right. So if you want to just visit it through the web, the browser, we use this HTTPS, but we're in GCP. So now we get to use Google storage. We go ahead, copy and paste like so, and then we submit the job and let it run. Right now, it's going to take about 5 minutes for this thing to run. So I'm going to go ahead, pause the video, and just in case you want to, after 5 minutes, you want to click on it. If you see it succeeded, then what we're going to go ahead and do is go back to Cloud SQL and query out the results. If it failed, we're going to look if there's some mission roles, permissions, some service accounts that need to get involved. If you have quotas that you're going to have to deal with, or any little thing that GCP might throw at you. So we'll be back. All right, so our job has completed. All right, and now we want to go ahead and do is go back to our Cloud Shell. You know, I was lucky that I haven't tried to clear, but that's okay. I try to keep my Cloud Shell instance going by interacting with it, but luckily it didn't kick me out. So let's take a look at some of the listings, some of the recommendations instead, right? So we take a look, And we go ahead and see, we see the recommendations that it thinks that the machine learning model will think that will best like. So for a user with characteristics of user ID 12, right, it will think it will think that the accommodations number 99, 59, and 49 are thus going to fit, as well as 38 and 66, right? For user ID number 9, it's 6, 30, 12, 22, and 3. If you just wanted to see what those what the names of those accommodations are, we're just going to do a little join statement here. User ID equals one. I said 6. I was working with, no, I was working with the user number 9. Go ahead, right? So now, right, we see it's a pleasant, quiet place, large, peaceful house, beautiful, peaceful villa, pleasant, peaceful house, and calm place. So number 9, user number 9 is probably an elderly married couple who are just looking, or a young or a middle-aged couple with some kids just looking to settle down in a neighborhood type of setting, a suburban type of setting. Let's look at a different prediction. Right, user number 12 had different interests. So let's see if that is changed. All right, look at also as well. This must be that large, quiet houses are where everyone wants to live. I would sure love to live in a large, quiet house. Let's try using number 5. Let's see if they have some different tastes. Right, so it's big, right? It might not be a private house, it might be something adventurous, right? But still giant and nice to live in is what everyone wants, is what mostly everyone wants. Or I didn't walk through them one by one, but as you can see, our machine learning model, especially the same for ones for the users for 9 and 12, they must be a middle-aged or elderly couple, and I guess all those people in that group would just love a large private house. So in result, that's how we do our machine learning model with Dataproc. So when you understand, Dataproc is basically a platform for Hadoop and Spark jobs, and Cloud SQL is a place that our data can go, where Hadoop, where Dataproc needs to access the data in a meaningful format, transactional data, right? So this is not a static table. This table you usually get updated probably every day, and machine learning models are needed for when the climate of the housing market changes and so on. Okay, and then one more thing is that once we're done with a machine learning model, we can go ahead and do, as advised, we can go ahead into Cloud SQL and click on the instance and go ahead and export our results if needed, right? I'll select our SQL query. Say if you wanted to select the best recommendations for that day, right? We'll use this query to look at the titles. Say for whatever the person needs to go out today, we'll take out one of these titles and so on. Great. So thank you. So that is all. Thank you for watching, and please, in your comments, if you do this lab, please let me know. I am available to help. Definitely will reach out to you with all the support that we need and any assistance with this lab. And once again, thank you for watching. Please like, share, and subscribe.